All right, welcome Math 1 to Section 6. This is Chapter 2, the very last section in Chapter 2. It is on dividing decimals. I'm not going to lie with you, I'm a little bit nervous doing this screencast. This is my very first one. It's kind of awkward teaching this in a room full of no students right now, but I'm going to give it my best shot. So if my voice cracks or if I seem like I'm acting weird, please give me a shot. This is new to me. Hopefully it works out for us. What I'm going to ask you right away is the question that I get most often in math class. Mr. Gillis, when am I going to use this? Dividing decimals can be used in everyday problems, specifically in a money problem. You know that money has decimal places behind it. Here's an example. You and a couple friends go out to eat and your dinner costs something like $18.75, and there are 4 of you and you want to split it evenly. You're taking a decimal and dividing it by a whole number, how many of you there are. It's very common to see these problems in real life. Okay, so let's get started today. I'm going to ask you to be able to do 2 things by the end of this. I want you to be able to divide decimals by whole numbers, like in this example, and I also want you to divide decimals by other decimals. I'm going to give you a strategy that I think works well, and hopefully it clicks by the end of this lesson. Okay, so follow along in your skeleton notes, and first up you will see that we have our key idea. It says dividing decimals by whole numbers. So that's the first thing you want to be able to do today. In words, all you have to do is you have to place the decimal point in the quotient above the decimal point in the dividend. If you don't know those 2 vocab words yet, quotient and dividend, don't worry, I've got an example coming up of what each one of those are. Then you divide as you would with whole numbers. So you just pretend it's a whole number when you're dividing, and you go until there's no remainder left. In numbers wise, it says place the decimal point in the quotient above the decimal point in the dividend. So same thing, it just is represented by numbers here instead. So you see that wherever the decimal is here, you just bring it straight up in your answer. So not a whole lot with that key idea. Just let me explain those 2 words to you quickly, quotient and dividend. There's a spot in your skeleton notes for this. It says label. So your quotient is your answer to your dividing problem. Your divisor is the number on the outside, and your dividend is the number that's on the inside of your long division sign. If I'm going a little bit too fast, feel free to hit pause whenever you need to in your skeleton notes so that you can get these down in time. Okay? I only have 15 minutes on these screen recordings, so I'm going to try to move a little bit fast. Keep up with me. Again, pause when you need to. Let's go to our very first example of dividing a decimal by a whole number. It says for letter A, find 7.6 divided by 4. Okay. This a lot of times can confuse students when they're setting up their long division sign. So write this down and actually put in arrows so that you know where each number goes. The very first number that's listed, 7.6, goes on the inside of your long division sign, 7.6. And the last number divided by 4 goes on the outside. So we have 7.6 divided by 4. Okay, our outside number is a whole number, we're good. We can just pretend now, after we bring up our decimal sign, so I bring up my decimal straight up, that it's a whole number. How many times does 4 go into 7? Just once. and 1 times 4 is 4. I'll subtract. 7 minus 4 is 3, and then I need to bring down my 6. And then you ask yourself, how many times does 4 go into 36? Well, that would be 9 times. And 9 times 4 is 36. Subtract, and there will be no remainder. Perfect. So my answer then is 1.9. Let's just estimate our beginning answer to see that if that makes sense. If I were to round 7.6 to something, looking at the 6, I would round that up, my next number up to an 8. So 7.6, the nearest whole number would be 8 divided by 4. Well, that's like saying how many times does 4 go into 8? And you guys know pretty basic would be about 2 is our answer. About 2, yeah, it's really close in fact. Be sure to estimate, sometimes it can really help you in math. So 8 divided by 4 is 2, and then so 7.6 divided by 4, 1.9 is a reasonable answer. We'll try one more, and then I'll have some on your own practice problems. Again, this first number needs to go inside your long division sign. 4.38 divided by 12. First step, I would bring my decimal straight up in my quotient. Then ask yourself, does 12 go into 4? No, it doesn't. 12 does not go into 4. So I'd put a 0 out in the front. And then look to your next digit. Does 12 go into 43? You bet. 12 goes into 43 3 times. And 12 times 3 is 36. I would subtract and come up. Well, I can't do that. I'd have to borrow. Comes a 3. 13 minus 6 gives me 7. 3 minus 3, 0. And bring down my 8. Okay, now I have to ask myself, does 12 go into 78? Yes, it does. 6 times. And 12 times 6 would be 72, if my math is right. Subtract, get a 6. Since there's nothing else left for me to bring down, I have to insert a 0 and bring a 0 down. And now does 12 go into 60? Yes, perfect. This time it goes in an even amount of times. 5 times, because 5 times 12 is 60. I'd have no remainder. So my final answer then is 0.365. In other words, 365 thousandths, because it's tens, hundreds, thousands. 365 thousandths is my answer. Okay. I'm going to give you these on your own problems. Please write them down in your skeleton notes and then hit pause on the video. That will allow you time to work out these problems, and then afterwards you can check your answer to make sure that you're doing these first problems right. Okay, I'm just going to put the answers up here because I've already gone through the examples. Check to make sure that you got the correct answer. Number 1, you should get 18.2. Number 2, 3.7. Number 3, 8.52. Number 4, 3.09. Number 5, 1.55. And lastly, number 6, you should get 0.195. If you have any questions about those answers, please feel free to come and ask me. Moving on. The second thing you want to be able to do today is divide a decimal by a decimal. Before it was just a decimal by a whole number. Now it's a decimal by a decimal. Again, pause if you need to take a second to write down your key idea. Essentially what we're doing in this problem is that we're multiplying our outside number by 10. What you want to be able to do when you divide a decimal by a decimal is to get your number on the outside of your long division problem into a whole number. See, they started with 1.2 here, and they got to 12. Okay, essentially all they did is they multiplied by 10. Okay, now if you move your decimal one spot here, you also have to move it one spot there. Okay, so it essentially becomes 45.6 divided by 12. That you will get the same answer in your calculator. If you took 45.6 divided by 12, you would get 3.8 if you took 4.56 divided by 1.2 in your calculator. Try that out. You get the same exact answer. Okay. Again, please have this in your key idea. It is on the second page or the back half of your skeleton notes. And now we'll try one of these examples. It says find 18.2 divided by 1.4. Again, sometimes kids can get stumped on this. Make sure your inside number is your first number listed. 18.2 divided by 1.4. And what we need to do when we divide a decimal by a decimal is we make sure we get this number into a whole number. Right? The way we do that, we can just move the decimal one spot to the right. So now instead of it being 1.4, it's 14. Well, if you move your decimal one spot to the right, you also have to do it to the number that's inside your long division. So now this problem becomes 182 divided by 14. How many times does 14 go into 18? Just once. 1 times 14 is 14. I'll subtract, get 4, and bring down my 2. How many times does 14 go into 42? Well, exactly 3 times. 3 times 14 is in fact 42. Subtract and we get no remainder. In this case, we have a nice even number. We get 13. Let's move on to letter B and try this one. It says find 0.273 or 273 thousandths divided by 0.39 or 39 hundredths. Right? First number goes on the inside of my long division sign, 0.273, and the second number goes on the outside, 0.39. Again, make your outside number into a whole number. To do that, I'd have to move my decimal 2 spots this time. So if I move my decimal 2 spots there, I also have to move it 2 spots on the inside of my long division sign. Right? Now, that makes this problem 27.3 divided by 39. Hopefully you can see here that my number is going to be less than 1. Okay, because 39 is too big to go into 27, so my number is going to be less than 1. Ask myself, can 39 go into 27? No, it cannot. Remember to bring your decimal point straight up. And then I look to my next digit. Can 39 go into 273? Yes, in fact it can. 39 times 7, this works out perfect, is 273. So when I subtract, I would get no remainder. And my answer then is 7/10 or 0.7. And box my answer. Go ahead and try the on your own problems for this section, and then I will put up the correct answers so you can check and see how you're doing and do a little self-assessment here. I might have to make another video to finish up this section. Alright guys, hopefully the video didn't cut off too short, but hopefully you got these on your own problems of dividing a decimal by another decimal for your answers. Hopefully you got ones that look like this. For number 7, actually as a whole number, you should get 8, 8.0, same thing. For number 8, another whole number, 17, 17.0, same thing. For number 9, 9.41, 9 and 41 hundredths. And then number 10, 0.9, in other words, 9 tenths. If you have a question about any of those, please come see me, let me know. Moving on to example 3, where in example 3, they throw just a little bit of a twist on it. They're spicing life up just a little bit with us. Let's check out the problem and see what we have to do. First number, 2.45 goes inside our long division sign, 2.45, divided by 0.007. This is 7 thousandths, tens, hundredths, thousandths, 7 thousandths. If you remember, we have to get this outside number to a whole number. So we have to move our decimal 1, 2, 3 spots. So we also have to do that to the number inside our long division sign. 1, 2, 3 spots. What do you notice where our decimal is? I think you see we have to insert something to insert a 0 into this problem. So it's just like saying we have 2,450 divided by 7. Okay, after moving our decimals. And the new decimal point is after the 0 now. We can bring that straight up, just like we did in our previous problems. And then go on as you would normally do your long division problems. How many times does 7 go into 24? 3 times. And 3 times 7 is 21. And subtract. 24 minus 21 is 3. I'm going to bring down my 5. Ask yourself, how many times does 7 go into 35? 5 times, which is 35. I'd subtract and get 0 and bring down my last 0. How many times does 7 go into 0? Well, 0 times. And 0 times 7 is 0, so there would be no remainder. The answer I get is 350. Remember, you can easily check your answer on these. Take 350 and multiply it by 7. We should come up with 2,450. 7 times 0 is 0. 7 times 5 is 35. Carry my 3. 7 times 3 is 21. Plus 3 is 24. In fact, we do. Our answer checks out. Okay. It does seem weird if you were to take and plug this into your calculator, 2.45 divided by 0.007, it does seem weird that your answer would be 350. Okay, but go ahead and try it. It will be. Because this equation, or expression I should say, is the same thing as this expression. Or the very exact same thing. Okay, a few on your own problems here to try with adding in those zeros when you move your decimal. Okay, again, pause the video, try those out on your own, and I'll put the correct answers up so you can check how you're doing. Number 11, 23.75. Number 12, you should get 20. Number 13, you should get 150. And number 14, you should get 60. Okay, again, come see me with any questions. Last example for the day is a real life example, and talks a little bit about the history of cell phones and how much they've changed and how many more people now have a cell phone. It seems like almost everybody has one these days. The question says, how many times more cell phone subscribers were there in 2011 than in 1991? And round your answer to the nearest whole number. Okay, let's look at our line graph over here. I notice on the bottom I have years, and on the y-axis I have subscribers, so how many people have one in the millions. So this, where we start at 1991, is actually 7.6 million people. Actually, it seems like quite a bit of people for 1991. And as you can see, wow, we are growing very, very fast throughout the years. And in 2011, not that long ago, there were 331.59 million people who had cell phone subscriptions or just had a cell phone plan, like with Verizon or AT&T. The question wants to know, we're comparing 2011 to 1991. How many times more were there in 2011 than in 1991? A lot of times when you look at this right away, when you see how many times more, it initially makes you think multiplication, but to find this answer, we actually have to do the inverse. We have to divide 331.59 by 7.6, and that'll tell us how many times more people have cell phones in 2011 than in 1991. Okay, we're going to use the same strategy that we have been using. Get our outside number to a whole number, moving my decimal one spot. If I move my decimal one spot there, I have to move it one spot on the inside number. So it becomes 3315, so 3,000, excuse me, 315.9 divided by 76. Okay. How many times does 76 go into 331? Oh, my guess is 4 times. And 4 times 76 would give me 304. If I subtract those, get 27, and bring down my 5. And then how many times does 76 go into 275? Guess about 3 times. And 3 times 76 gives me 228. Okay, I'll subtract those. Come up with 47. And bring down my 9. One thing I forgot to do right away is I didn't bring up my decimal. I can do that now. 43 point something. How many times does 76 go into 479? I'm going to guess 6 times. That gives me 456. Subtract, and I'd get 23. Now I can stop right here because my answer said round to the nearest whole number. So I just needed to go one spot beyond the decimal, and I got 0.6. If I look at this 0.6, the number is above 5, I know to round up. So I can round 43.6 to about 44. Now think about this in the context of the problem. What is it asking us? How many more times cell phone subscribers were there? So our answer should be about 44 times more. Wow, 44 times more. Even if you think about how many 2 times more is, 44 times more. You can really see how cell phones have exploded in the past 10 to 15 years. Absolutely unbelievable. Alright, that's our last example. That concludes our lesson on dividing decimals. Again, this is the last one, last section in Chapter 2, so upcoming will be our Chapter 2 test. If you do need a little bit more help, if it's still a little bit confusing, be sure to check out this Khan Academy video. Sal Khan does a wonderful job explaining some math concepts as well. If you have any more questions on anything, please feel free to let me know. Let's get started on some of our practice problems. Hopefully this helped. Hopefully this very first screencast is good, went well for us. Thanks everybody for paying attention, and Mr. Gillis is out.